Welcome to today's episode. Possibly I'll talk about chemical equilibrium in this case. So chemical equilibrium, we'll just talk about the reactant should be equal to, or reactant is equal to product regardless of the states of the compounds or molecules there. In this case, if we say A plus B is equal to, or should I say is equivalent to C plus D. That means this reaction is a reversal reaction. Possibly we can try to react CD to produce AB, or we can try to react AB is equivalent to CD. That shows to say this chemical equilibrium. So now, in this case, the question might come to say, really here, the question might come to say, express this equation into, or express or light equilibrium expression of the above reaction. How should you go about it? In this case, since it is a chemical equilibrium, possibly we use Kc as constant equilibrium there, possibly or that constant equilibrium there is equal to product over what? Reactant. Reactant, or let me say product over what? Reactant. And in this case, we pay very much attention to the what? To the coefficient. In this case, as usual, before going any further in chemistry, you have to make sure that you have balanced the equation. So if we have 2 here, just trying to assume, then here 3, then here 2, then there 3, what possibly will happen under chemical kinetics here? We consider a coefficient of A, coefficient of B, C, D, very much relevant in this case. So Kc is equal to, if I replace like this, that means the concentration, getting the concept from chemical kinetics. So this is concentration of what? C. And what is the coefficient of C? It is what? 2. Hence, that coefficient is going to be powered above their concentration. So what will happen? What about D? D, it is what? 3. Same applies there. Same thing there. You come back to reactant. It's the same thing there. You come to what? B there. It's the same thing there. So that's how we try to light the expression of this reactant and product in chemical equilibrium. So I'd like to leave you with this question or this homework so that you can try to solve it. They'll say that this is homework under equilibrium expression, should I say chemical equilibrium. So we have ammonia reacting with oxygen to produce nitrogen dioxide there, and also steam, which is in form of what? Gas. So, and the question is very much balanced. So hence, light equilibrium expression for the above reaction. Please solve it, and the answer are needed, or solutions are needed. So let's try to solve the next problem under chemical equilibrium. We have this problem calculating K, which is chemical equilibrium. In Haber process, possibly Haber process is the formation of ammonia as one of the perfect riser that is common in most of the areas, whereby reacting hydrogen plus nitrogen to produce ammonia. And do not worry about the reaction possibly being provided in some of the question papers. So we have ammonia with 3.1, nitrogen 8.5, hydrogen 3.1 times 10 to the negative 3 mole per liter. Then the question is calculate the value of K. So as the data being provided, write your data here clearly by indicating that what you have. So what you have there, you have ammonia, which is equal to 3.1 times 10 x to the negative 2. You have nitrogen, which is equal to 8.5 times 1, or times 10 to the negative 1. Then you have hydrogen, or the concentration of hydrogen, and the rest is equal to 3.1 times 10 exponential what? 3. Hence the question is, what's your K? The question you don't have. So, okay, you don't have. So as usual, like what I said, it's a Haber process. So that means to say it is nitrogen in form of gas reacting with hydrogen in form of gas, producing, um, it can be a reversal, or it is a reversal producing what? Ammonia. So as usual, before we go any further in the chemical kinetics, because you consider that a coefficient, you're supposed to balance it. How many nitrogen do you have? I've got 2. How many nitrogen do you have this side? I've got T. Only 1. Hence, to balance it, you're supposed to put 2 there. That, in this case, introduction of 2, nitrogen is balanced, but we affected what? We have affected hydrogen. How many hydrogen in this case? I've got 6. How many hydrogen in this case? I've got 2. We put 3 there, and the hydrogen is balanced. So hence, you need to write down what? Our Kc expression is product over reactant. What's the product in this case? It is what? Ammonia to the power 2 over the concentration of hydrogen. But much important to putting a concentration there to the power 3. That is the expression that we have over there. So what is the next thing here? Nothing to worry more about. It is Kc is equal to start expressing because I've been given data there. What's your data there? It is, you open up concentration which is equal to 3.1 times 10 exponential negative 2. What is being powered there? It is 2. Divide by what is your nitrogen there? Your nitrogen is 8.5 times 10 exponential 1. You open up another one because there is nothing there but to the power 1. What is your hydrogen? Your hydrogen is 3.1 times 10 exponential what? 3. Hence, that is your expression. It is being exponential negative 3. And what you have up there, you have 3. So that is your equilibrium expression. Possibly they are supposed to go ahead in terms of calculating. Now, I'd like us also to give you or to finish up this so that I can try to engage you in solving and also in understanding. So possibly I need the answers, try to finish up that, and let's try to solve the next question. In this case, we have nitrogen, or let's say nitrogen monoxide reacting with chloride to produce nitrogen monoxide chloride. So that is what we have on the table there. And in this case, something strange here, we're not dealing with concentration, we're dealing with P. P means pressure. So we're dealing with pressure there. That's why we even see the units there that has changed from ATM. Possibly there the temperature can be in Pascal or that ATM that we have. That's why you may find to say I've told you to calculate the value of Kp instead of the value of K or Kc. In Kp, you're talking about that constant of pressure there. So you're supposed to calculate Kp. Hence, how are you going to go about it? Nothing difficult here, is one and the same, but the expression is going to be a little bit different from that of Kc. How are we going to go about it? Let's go. So before going any further there, what's your equation? The equation is 2O there in form of the gas. Then we have chloride there, which is in form of the gas. Then we have nitrogen monoxide there, chloride, which is in form of the gas. Then this balance there, something like that. And the equation is balanced. So before I go any further here, we have to write your Kc expression or Kp expression. What's your Kp expression? Here it is. As usual, so Kp instead of Kc is equal to. Now here, I want to use, it is product of a reactant, yes, but we want to use these blankets because this is reaction or symbol of concentration. That means we're going to use parentheses instead. So we say that open up parentheses, then we put a P here. That shows to say it's pressure. Pressure of the what? Pressure of nitrogen monoxide chloride. We close. What's the coefficient there? It is what? 2 is powered by 2. Same applies if down here we open up that parentheses, then P there, nitrogen monoxide close is equivalent to or being powered by 2 as a coefficient, and chloride there, we doesn't have anything there. Then once you have that, then possibly here, what is your data? Your data based on what you've been given in the question, I said Pn or L is equivalent to 1.2 atm. Then you have PNO is equivalent to 5.0 times 10 exponential negative 2. Then you have PCl2 is equivalent to 3.0 times 10 exponential what? 1 there. Hence, ATM. Hence, try to calculate, try to replace them, and find the value of KP. It is the homework that I've been given for you, or let me say, to engage you in terms of understanding and improve your skills of calculations, possibly try to solve them. Hence, let's try to solve one more question, one more problem under chemical kinetics.
Okay.
Okay, we've been talking about relationship, or we've been talking about Kp, Kc, or let constant concentration, let constant pressure. But really, what is the relationship between these two? The relationship is in between, or is coming from the combination of Avogadro's, the combination of Boyle's law, Charles's law, then later on forming hydrogen gas. Last one, the relationship coming from. Hence, can you try to put them together under chemical expression, chemical equilibrium? What will be the relationship here? This is an examinable question you might be asked to find the relationship between those pressure and concentration. What I'm going to do here, first of all, we start with Kc expression, which is product over reactant. We're going to have ammonia there, or the concentration of ammonia to the power 2. This Kc, hence I'm using concentration. This symbol means concentration over nitrogen here with no any coefficient there. Then we have 3 hydrogen, or should I say hydrogen gas there with a coefficient is equivalent to 3. You agree with me? In this case, we're going to change the perspective. How are we going to change it? I'd like you to take you back. To take you back, you all know that if you have PV, or the combination of ideal gas, or the combination of Charles rule, Boyle's rule, and the Avogadro's is equal to PV, then ala or N ala what? T. Pressure, volume, this is coming from Boyle's law and Charles's law. Then temperature, it's coming from possibly there Charles's law. Then I've got nitrogen from Avogadro. I mean any number of moles from Avogadro's. Then ala there as a universal constant. In this case, it has changed, not even a converted one. In this case, we're not using 8.3415, but we're using 0.826. But don't not worry about it because I won't even use it. But that is under hydrogen gas law. Whatever happened here in this case, if we want to make P as a subset of formula as usual, since we're dealing with the relationship between K and Kp, we know this over V there, then here over what? V. Yes, this one gone. What are going to remain with? We're going to remain with what? N ala T there over what? V. If I may try to ask you this question, what's the formula of concentration? Is concentration over what? Number of moles over what? Volume. That means this one is equivalent to what? C ala what? T. Just replacing where is N over V, we put what? C, and hence we have what? C there. So now, what will happen? That means we're going to have P is equal to what? C ala what? C ala T. In this case, that means if you're looking for the value of C there, or the value of C there, I'm going to say over what? Ala T over what? Ala T. So this one gone. What's your C? Your C is equal to P over what? Ala T. So as our concentration that we have. So now, this means concentration. This means concentration. That means C also it means concentration. So whatever of least concentration are going to do what? We're going to remove them and possibly replace them. So we're going to say P NH3 over ala T. We close to the power 2. Why am I using this parenthesis? Because this blankets means concentration, hence I've replaced by putting P over ala T multiplied by NH3. We're going to have this because getting this concept here. And once we have that, over the same thing down here, it is to be P N2 there over ala T The same thing there, P in, hydrogen there over RT to the power what? 3. You all agree with me? If you do some mathematics there, this is equivalent to PNH3, talking about pressure there, to the power what? 2 times 1 over RT to the power what? 2. That shows that um, this is equivalent to this. Also, we do the same thing to that of the down there. It is PNH2 close times 1 over RT. I'm not putting anything here because we do not have any coefficient under what? Nitrogen here. Then we do the same thing here for hydrogen. It is the same thing there. There is 3 there times times 1 over T over there to the power what? 3. As we have on the table there. Then what will happen after we have that? Possibly here, I'm going to hold on this, which is, or let me say, allow me to utilize or solve this animals there, which is 1 over RT squared over 1 over RT cubed, which is equivalent to 1 over RT squared divided by 1 over RT cubed, which is equivalent to 1 over RT. We try to put it into multiplication, change it to multiplication, then RT goes up there, and you're going to have that over 1 here. And what will happen here? This into that are going to remain with only with what? T, as in possibly here it is a squared, by the way. Yes. So this into that we're going to remain with what? RT. So this is what we have here over there, or that we have over there. So what will happen here? This means that since we're looking for Kp, hence Kp is equal to open up R what? RT. That's what we have remained with there. And in this case, if we're looking for that, we're having that equation. It is P N. It is P N H 3 to the power what? 2 over PNH or PN there, and we have PH what? 2. Hence, this is a relationship of K and Kp. It is Kp, open up RT. That is our relationship. I would like you to go through to identify if there is anything along there, and also if there is anything that you might be asked or you try to ask to find out more information. Hence, I would like to leave you with this homework. The homework down here, it is you to find the relationship between Kp in the reaction of, or in the decomposition reaction. In this case, we are trying to, this was HAPA, the process, which is a combination to form that ammonia, but this is a composition. You're trying to break down ammonia to nitrogen and the hydrogen, and try to calculate or to find the relationship between Kp and the Kc, or K and the Kp. This marks the reaction or the end of chemical equilibrium problems calculations. See you in the next episode. Thank you.